Welcome to the Antibodies Lab. A young couple are visiting the office of one of our collaborating physicians, Dr. Lee. They have some questions about rhesus disease. Dr.
Hello, I'm Dr. Lee. Welcome to my office. Today I will be your consulting obstetrician. How can I help you?
Hi, Dr. Lee. We are here because we are pregnant with our second child and are a bit worried.
We've read about rhesus incompatibility and that this could cause problems during my pregnancy.
Can you tell us more about rhesus incompatibility and the risk for our baby?
Of course. When a rhesus-negative mother carries a rhesus-positive child, she may be exposed to rhesus-positive blood during pregnancy or childbirth. In that case, the mother's immune system may recognize the rhesus antigens on the fetal red blood cells as foreign and produce antibodies against them. This can cause immune issues in later pregnancies in which the baby is rhesus-positive because these antibodies could cross the placenta and attack the baby's red blood cells, causing hemolytic disease of the newborn, or HDN for short.
That sounds really dangerous. Can we test to see if our baby will be affected by rhesus incompatibility?
Absolutely. I will schedule blood tests to check your rhesus status to see if further treatment is needed.
Using the lab pad is an important way to get the most out of this simulation. Perfect. Then let's get started with your first mission.
So, Joel and Carmen are expecting their second child and want to find out if there is rhesus incompatibility between Carmen and the baby. Click on the lab coat rack on the right to wear a lab coat. Awesome! Now that you're safely dressed for the lab, let's help Joel and Carmen. Wait for further instructions from Marie.
Hey there, I'm Marie. Before we get started, let's talk about the key players in our mission: antibodies. Antibodies are super important when it comes to protecting us from viruses, bacteria, and other pathogens. If antibodies and antigens can bind together, which statement is true of antigens? Option A: they are molecules capable of triggering an immune reaction. Option B: antigens are glycoprotein free-floating in the body. Option C: antigens bind to cells to protect them from destruction. Option D: they are molecules only present in newborns. Well done. An antigen is any molecule that can cause an immune reaction. These molecules range from proteins, nucleic acids, to whole organisms. Have you ever had hay fever? Then the antigen was probably pollen, which stimulated your immune system and made you sneeze. Antibodies are also known as immunoglobulins, or for short, IG. They are Y-shaped proteins with hypervariable regions that recognize
Go to Workbench 1 to look at the molecular viewer. Looking around is not supported here. Click on the antibody button to observe the structure. Here you can see a hologram of an antibody, just like the one which causes problems in rhesus incompatibility. Isn't it a beautiful Y shape? An antibody consists of two long chains called heavy chains and two short chains called light. Can you see the different chains in the hologram? The two heavy chains wind up the molecule from the bottom. One fades from green to turquoise in color, and the other fades from red to orange. The two light chains at the top of the molecule are colored yellow and blue.
How many polypeptide chains build up an antibody? Option A: 1. No, this is incorrect. How many polypeptide chains? Right on. You're a great observer. Every antibody is unique, like a fingerprint. They are produced to fit and detect only a single antigen. Binding of the antibody to the antigen happens at distinct regions. In mammals, there are 5 different classes, or isotypes, of antibodies: IgA, IgD, IgE, IgG, and IgM. They are categorized according to their biochemical properties and fulfill different functions in the body. These regions are different for every antibody and specifically bind to what. According to the theory, which antibody isotype crosses the placenta? Option A: no, this is incorrect. According to the theory, no, this is incorrect. According to the theory, which antibody isotype crosses the placenta? Option A: IgA. Option B: none. Option C: IgG. Option D: IgM. No, this is incorrect. According to the theory, genius. IgG is the. Let's see if you can identify the structure.
Click back to return to the lab center and head over to Workbench 2 on the left of the lab room.
Looking around is not supported here. Click on the laptop on the workbench in front of you. Label the different parts of the antibody and the antigen. Use the theory for help if you need it.